Okay, guys, welcome again. We have to remember some formulas which will be very much important for this purpose. Just write down sin in pi equal to 0. Okay, some formula I will tell you. First, now we'll go for an example so that we can realize the Fourier series. Write down this example. Okay, you can see this signal. This is a function of t. This is your signal, and this is your time domain. Okay, so this is your signal. No mathematical expression is given, so you have to find out it. What is we have to find out? That is Fourier series of this waveform. This waveform is given. We have to find out the Fourier series of this waveform. Okay, just write down. This is very important task for you. Now we know the fundamental equation. What is the Fourier series trigonometric equation? Just remember that is function of t equal to a naught plus summation of n equal to 1 to infinity, a n equal to 1 to infinity. Then what happens? It first bracket is started. Then a n cos, always cos is with a n, cos a n in omega naught t plus bn sine and in omega naught t. Okay, that is your fundamental equation. We have to find out for Fourier series analysis. We have to find out a naught. We have to find out bn, an. We have to find out an from this equation. Okay, then we can easily express the Fourier series waveform, and then phase spectra, amplitude and phase spectrum. So for Fourier series analysis, we know that is function of t equal to function of t plus t, that is time scaling. Okay, the waveform is continuing second time of this period. The waveform is continuing for the second time of this period. Okay, look, this is first period, this is second period. Okay, so t is 2 and omega naught is 2 pi by t. Okay, if you put this t equal to 2, then omega is 2, means frequency 2. Okay, up to this I think it is clear. If I put this, then this is 2 because this 2 sorry, this is pi, this is pi. This is not 2, this is pi. Because if I put this 2, then 2 and 2 will be cut and pi will be oddly repeated. Okay, so omega is pi, half pi, 2 pi. So first step, that is find out the A naught. A naught is what? So A naught is 1 by t. Just remember this formula, 0 to t, 0 to t, function of t dt. Okay, it is, so it was, this was the formula we have just evaluated. Then putting the value of t, that is 2, value of t is 2, 2 times it is repeated. So 0 is 1 period, that is function of t is 1 dt plus another portion 0 to t, that is 0. Whenever, that is, the period is 0 to 1, that is 1, but whenever 1 to 2, that is, 0. Okay, this portion is 0, so we are putting this 0. That is 1 to 2. Okay, so we can find 1 by 2, that is t equal to 0 to 1. It is only this portion, so we get, that is half, because this is 1, so that is half. So we can find out the A naught, that is half. Just remember these things. A naught equal to A naught equal to half. Okay, now second step, find out an. We know an equal to, just remember this formula, 2 by t integration t, function of t. Just remember we have multiplied with the cos n or cos m, so we can get, that is cos n omega naught t e dt. Okay, this is your formula we have find out. And now we just keep it t equal to 2, because we have the two signals, that is 0 to 1 and 1 to 2. Okay, that is 0 to 1. Just remember, that is 0 to 1, that is amplitude is 1, but 1 to 2, that is 0. So we have to always integrate step by step, that is 0 to 1, you have to put, that is 1, function of t is 1, and then cos in omega naught t dt. Okay, plus fit 1 to 2, this 1 to 2, this 1 to 2, that is 0, so that is 0. So this is cos in omega naught t dt. Okay, so this part is 0, and we know omega. What is the value of the omega? Value of this omega is pi. We have decided, because this is the frequency is pi. So we can put the value. This is 2 t equal to 2, that is 0 to 1, that is 1 cos n, that is omega equal to pi, omega equal to pi, and t, and this is dt. This part is 0, so it is integrable. If I integrate it, then this cut it. If I integrate this, what happens? This one is coming outside, and if I integrate, then it became, cos became sine, and this n pi became n pi, n pi, that is sine n pi t, and that is 0 to 1. So if I do this, an is from this, an is 1 by n pi, this n pi out of bracket, then n sin n pi minus sin 0. Sine of n pi is, it is always 0, so it's became 0. So our en is 0. Our en is 0. Okay. Now we have to find out the bn. Step 3, have to find out, that is bn. Okay. So bn equal to, our formula is 2 by t integration 0 to t. Remember, function of t, it was multiplied with sine m, so we are getting sine m or sine n, sine n omega naught t dt. It was your formula, you have just evaluated in the previous class. So just putting this value 2 by 2, you have to break this because your signal is just like this, 0 1 2. So your signal is just like this, so you have to break this 0 to 0 to 1, that is 1 sine n omega naught t, plus, that is 0 to 1, that is 0 sine n omega naught t dt. Okay. So this was cutted, and we are getting only this 0 to 1 sine n omega naught t dt. Okay. So if I got this, then what happens? Then if I integrate this n omega means that is n pi, omega is pi, we have decided omega is pi. So this became 1 by n pi, n by n pi into, that is cos, sine is converted into cos n pi, that is 0 to 1, 0 to 1. So we are again doing this 1 by cos pi minus cos 0. Okay, that is n pi. Okay, so we know cos 0 equal to 1. We know cos 0 equal to 1. But what is the value of this n pi? Value of this n pi, n equal to, now it is 1. But if cos n pi equal to minus of n, if cos n pi is the minus of n, then we can write n pi equal to minus of 1. Okay, that is 1 to the power minus n. If this is 1, minus 1. If this is 2, then plus 2. So minus 1, this minus 1 is coming. So you can see there is a two value is existing. First one is, if there is a 2, n equal to odd number, n equal to odd number, then what happens? If I take, sorry, this is a minus term. This is a minus term is there because sine to cos, this is a minus term is there. Okay, so always minus is there. If I'm taking the common of this minus, then what happens? 1 n by pi, that is, this minus is coming under, so it is coming minus of minus n. Okay, if it is odd, what happens? Then look, this is odd, then this is, uh, say this is 1, then this is minus 1. So this is plus 1, plus 1, plus 1, this is 2. So it will give you odd. If this is odd, this give you n pi. But if this is even, then it will give you 0. Okay, so by this way, by this way we get an a0 a bn. Okay, so we can write this for the function of t, a naught equal to just a1 cos omega naught t plus b1 sin omega naught t. This is first harmonic plus a2 cos 2. This is 2, n equal to 2. Okay, omega 2 naught plus b2 sine 2 sine 2 omega naught t plus a3 cos 3 omega naught t plus b3 sine 3 omega naught t. We can write down up to infinite time. A4 cos 4 omega naught t plus b4 sine 4 omega naught t. Just remember the equation. Okay, summation is there and going on. Okay, so just putting the value of this, that is 1 by 2. You can see this part was 0. A0 is 0, that was this part was 0. B B is the 1. If this is odd number, then this is 2 by n pi. Then 2 by n pi. A2 is 0 and this is even. So this is 0. Okay. A3, that is 0 because an is 0 and this is odd part. So we can see this is 2 by n pi. Okay, this is 0 and this is the again even part. So this is 0. In this way we can get this value. So half plus 2 of pi 2 of pi, because this is the value of b, this is the value of 0, this is the value of this plus 2 of 3 pi sine omega naught t plus 2 of 5 pi, only n equal to 1 3 5 7 9, this, so 2 pi by 2 by 5 pi into sine 5 omega naught t, and it will go on only odd number, n equal to odd. Okay, I think up to this you can get this point. Okay, so function of t, you can write down only contains the dc component and the sine term with fundamental and odd harmonics. Okay, so if you summarize this, then we can get half of t, that is an plus 2 by pi. This 2 by pi is common. 2 by pi is common. Summation of n equal to 1 to infinity it by 1 by n. This n 5 3. This is n and sine n pi by t. Okay, so this is the ultimate Fourier series expression or Fourier series analysis of the signal, this type of signal 0 1 2, 3. This type signal is converted into Fourier series signal. So we have to, now new slide, we have to express this. Just write down this signal, what we will get, that is function of t equal to half half plus 2 by n, 2 by pi, 2 by pi n k equal to n to infinity 1 by n sin n pi t. Okay, where n equal to 2k minus 1, always odd. 2k minus 1 is always odd. Now there is a one DC components, one sinusoidal components. So if I watch this, so this is a DC component, that is 1 by half, that is 1 by half, that is your DC component. And another component is there is a sinusoidal component. Okay, this is your sinusoidal component, this part. Okay, so for this first harmonic you are getting this type of signal, means your first harmonic you are getting this type of signal. Okay, only what if we apply for the second harmonic, because n equal to 2, then you can get within this look, second harmonic we can get these two signal. Okay, if I apply for third harmonics, we get, look, period is same, third harmonics we get this type of signal, this type of signal. Okay, for your fourth harmonics, fourth harmonic, 1 2 3 4, 1 2 3 4. Okay, your fifth harmonic, 1 2 3 4 5, 1 2 3 4 5. Okay, so guys, you can see for the first harmonics it is sine wave, second harmonic it is also look like a sine wave, but whenever it is going to the fifth or the nth other harmonic, you can find that is just like your square wave, just like your square wave, that is nth other harmonic, nth other sine wave harmonic. So it is just like your square wave. So any signal, from this example we can understand any signal can be, if this is a periodic signal, can be expressed in a Fourier series, which is the sinusoid summation of infinite summation of sinusoidal signal. So this was your signal, this was your signal. Okay, this 0 to 1, that is 2. This signal is converted into these two type of signal. Okay, these two type of signal, if you go for infinite summation, it is also getting this. Okay, if you summation of this, then you get this type of signal, because this is negative and this is negative, so this is positive. You know, if I add this type of signal, if I add this type of signal, ultimately the signal will coming, sorry, if I add this signal, then this is negative part, then ultimately our signal is coming this. So you can see this is a continuous DC signal, and here this is a, after half period there is a negative part, so it will give 0. Okay, in this way, and this is the average value, this is the average value half, and this is also going to the by 2 pi. So in this way we get this signal. So this is the Fourier series expression, and our question is not completed over here. Okay, they asked the phase and amplitude spectrum. So we can know that is A not equal to 0 and A in, what is A in? A in is A in square plus B n square. So we get A n is also 0. So only Bn is coming, only Bn is coming. You have seen that A not is 0. So Bn is only coming. So Bn is available when 2 pi by, sorry, this is not here. Bn is available in when in n equal to odd, and that is coming 0 when n equal to even. Okay, so phi n equal to minus of tan inverse, that is bn by an. So this is 90 degree minus 90 degree when that is odd, and 0 when n equal to even. Okay, and by phase spectra, and this is the amplitude. Okay, amplitude spectrum, that is first time, that is pi, 2 pi, 3 pi, 4 pi, 5 pi. Okay, amplitude is at this pi, that is 2 pi, that is 3 pi, that is 4 pi, that is 5 pi. Okay, that is 2 pi, that is 2 by pi, that is 2 pi, 2 by 3, that is 3 is nothing there, that is 2 by 5, 8 pi. Okay, in this way, this is omega. And if I got this 0, this is phase, this is angle, amplitude, and this is the phase spectrum, that is minus 90, that is plus 90, that is pi, 2 pi, that is 3 pi, that is 4 pi, that is 5 pi. So in this case, only phase is here, only odd is there. Okay, odd is there. So pi is there, then it is minus 90. So this is minus 90. Feed 2 pi, this is 0. Feed odd, okay, then this is 0, this is odd. So this is the amplitude spectrum. You can put over there n equal to odd. This is not in 2, this is not in 2, this is 3, this is 3 pi, this is 3 pi, this is 5 pi. Okay, 3, 5, 7, etc. So just put this and you can write this. Just I am doing here again. You can write down, sorry. This is pi, this is 2 pi, that is 3 pi, that is 4 pi, that is 5 pi. I am taking up to 5 pi. Okay, so this is omega and this is amplitude. Amplitude is given over here, that is only depends on Bn. So n 2 by n by 2. So when this is 1, odd is exist, even is not exist. So that is 2y in pi. Okay. So that is n equal to 1 means pi. So that is 2 by pi. This is 2 by pi. 2 by pi. If n equal to 2, then it is 0. N equal to 3, so 2 by 3 pi. So its amplitude should be here 3. Amplitude should be something less. Then n equal to 5, then 2 by 5 pi. Then again amplitude should be this. So this is your amplitude spectrum. Okay, in this way, this is 2 by pi, this is 2 by 3 pi, this is 2 by 5 pi. Okay, this is your amplitude spectrum. And this is your phase spectrum. Okay, this is your phase spectrum. This is called. So guys, we this is our complete answer. But main thing we have to realize that the first statement. Yes, yes. Tell me. Yes, tell me. If you have any question, you may ask me. Any question? Look, first, realize the statement. Any periodic signal, which was the Fourier statement, any periodic signal could be expressed in the infinite summation of sinusoidal waves. Any periodic signal could be expressed in infinite summation of infinite summation of sinusoidal signal. Look, this is the any periodic signal. This is your periodic signal. Okay, it is repeated in the period of pi. So this periodic signal could be expressed in this way. Though this is giving sinusoidal, but if you analyze this, then it became a just like a square wave. Infinite. Why this is called infinite? If you go for infinite, then it will reach to this. Then it will reach to this square type wave. Okay. So this is the main statement, and I think from this example we can realize the Fourier series. Okay, Fourier series signal. So guys, if you have any question, you may ask me.
Yes, sir.
Yes, yes, tell me.
At the beginning of the solution, there you took t is equals to 2, from where that 2 came.
Where? Here.
So at the very beginning.
Very beginning. Here.
Yes. No, no, no. So that after the question you wrote, no, f of t is equals to f of t plus the one more t is there
Hmm. I
at the
just
very beginnings.
very beginning I have just deleted this slide because this is a paint. Okay, just tell me where is your problem. Half of t.
Uh, the value of t you took 2. So from where
Yes.
you
Value of t is taking 2. Why value of t is taking 2? First, realize this signal. Very beginning, your signal was just like this. Okay, -2 to -1, that is 0 to 1, and that is 2 to 3. Okay, from this signal, we have to realize why this is 2. Time period is 2. Okay, time period is 2. You can see, because one signal complete cycle, you can see complete cycle is taking 0 to 2. So this is 1, 0 to 1, 1 to 2, this is 2. So time period is 2. If this signal is completed within this is 1, then we can say this is 1. If this signal is completed 1, 2, 3, if this is completed within this, then we can say that is 1, 2, 3. So T is 3. So here it is completed this cycle. This is completed here cycle. Again it is started. Again it is going on. So you can see every signal, each signal taking this up and this up. So this is 1 and 2. So this is taking this up and this up. So this is 2. So that's why we are taking this is 2. Is that clear?
Okay, sir.
Okay.
Okay.
And all time we have split this signal. When something is coming, we have split this signal. Integration 0 to 1, we get 1, and again 1 to 2. This 1 to 2, then we always write down this 0. Okay, because total signal you have to take this function of t. It was a function of t. Then you can find that is 1 when that is t lies under 0 to 1. We have to express a simplest form of this signal. Then we can, it is a periodic and repeated signal. So t is lies greater than 0 and less than 1, or less than or equal to 1. But when this is 0, when t equal to just greater than 1, just greater than 1 and less than 0. So this is 0, just greater than or equal to, you can say greater than 1, and just less than 2, then it becomes 0, and 0 to 1 it is 1. So that's why this signal has the two part. We always break this in the two part. Just remember this equation, and we are taking 2. Why? This is a time period is 2. This taking 2 second, 2 unit of time. That's why t equal to 2. Okay, and we know the formula. What is the omega? Omega is fundamental is 2 pi by t. This is your formula. So if we put this t equal to 2, then it is cut it. So omega it became pi. So always I write down omega is a pi. Okay, in this cases no signal was given, but just one picture was given. From this picture we have to analyze this. Okay, so my aim is to make you understand about this Fourier series, because uh, we have read this Fourier statement. What is signal? How it is added? But here through this example, we can understand if I go for infinite time of summation, then this signal looks like this, just like a square wave. And if you add this square wave, then you get this. Okay, any signal, any periodic signal could be expressed in the infinite summation of sine signal, sinusoid signal. So infinite summation of sinusoid signal, we can make this signal. So this signal converted in this way. So this is the Fourier statement, and I think from this example we can realize this thing after the end. And this part was your question part, but main realization was here. Main realization was here. Your signal is there, and this is from DC component, this is from AC component, and we achieve this signal from the fundamental equation. Okay. Okay, thank you guys. I am going to stop here. Okay, have a nice day.